So this is our second lesson on looking at quadratic functions and their graphs. We're particularly focusing in on the completed square format, which can look a bit like this, where you've got y equals x, then plus a number, then the brackets closed with a squared sign, and then plus or minus a number at the end of that. Or it might also look like this, y equals x, might have a minus in the brackets, with a number at the end. So how do we interpret when we're given the equations in this format? And basically what we know is that when it's presented to us this way, the one point that we can tell about the graph is that there will be a turning point, and the x coordinate of your turning point will be the opposite sign of whatever is in the brackets here. So in this case, if we had x plus 2, for example, that would mean what would go in the brackets would be a minus 2 for the x coordinate. So it's always the opposite sign. So a plus there means it'll be a minus for your turning point. Your plus C at the end, if whatever that is, that could be minus 5, and it'll still be minus 5 here. It will match. So the y coordinate of your turning point is the same as the x, as the c value. So the key thing about all of this, right, is that we are working with being able to identify the turning point. And when we're identifying our turning point, something else that you're sometimes asked about is the nature of the turning point. Now, if I was to multiply all these brackets, I would get a positive x squared. So because it's a positive x squared, we will also talk about the nature of the turning point will be, that's how you spell minimum, a minimum turning point. Right, that was something else that we spoke about. So minimum turning point. If you've got a positive x squared, so if you're a very positive person, then your shape of your graph will be like that. We spoke about the fact it would be a parabola shape. It comes down, and it's this turning point where it changes direction that we're writing down the coordinates of. So these are the things you need to remember. Once you've written down the turning point, you can get what's called the axis of symmetry. So these parabolas are symmetrical, and you can find the equation of the line that would go down through the centre of this. So we could draw a line down the middle from this point here. So if we pick up a line, so picking up a line, sorry, and draw it down through, right, that's your axis of symmetry. So this axis of symmetry will go through the turning point, and everything about that should be symmetrical. So looking at the other one, if you start off with an equation that's already got a minus in the bracket, it means that your turning point will have a positive x coordinate, so it'll be the opposite sign. Whatever is at the end, that will just match exactly, and your axis of symmetry will have the equation that's the same as the x coordinate of the turning point. So something that we didn't really go into in detail and that I need you to be able to do, and this you can pause in the video and maybe copy this down, or else wait to the end of the video and then use the notes to copy this down. But we do, with these equations, as well as identifying the turning point, we might need to identify the y-intercept. You came across that term when we were doing work on straight line equations, where the y-intercept is a point on the x-axis, the y-axis rather, right? Y-axis intercept is a point which lies on the y-axis, and actually any point that lies on the y-axis is going to have x coordinate equal to 0. So one of the key things here is that if that's something you can remember, right, points on the x-axis all have x coordinate equal to 0. So basically, if you know the equation of the curve, you can sub in to that equation, replace the x with the 0, and work out a value for y, and that value for y will be your y-intercept. So in this case, this was in a previous, in your notes, this example, you weren't asked for the y-intercept, but I'm just showing you how to work it out. So the turning point clearly is at 3, 7. If we sub in, replace the x with 0, we get 0 minus 3 in the brackets, that's minus 3, but that needs to be squared, that gives us positive 9, and then we've got to add on the 7 at the end, that gives us 16. So what that would tell us is that this point here, right, would be the point 16, and once you've worked that out. For example 2, right, again this was one that I know in your notes, the equation of that, remember that's the point is 2, so in the brackets it must have been minus 2, whereas this here matches, you've got the minus 5 going on at the end. So always remember the x1's always the opposite sign. That's the equation of that curve. So to work out what this point here is, which is our y-intercept, you'd sub in x equals 0, and that gets you your y-intercept. So 0 minus 2 gives you minus 2 in the brackets. Any negative number squared, that means multiplied by itself, going to give you a positive, so you get 4 minus 5, so you get the fact that that there is the point minus 1. And that's us worked it out. So we now know how to work out the y-intercept. We're going to have a look on your notes, if you can go to page 30. We didn't complete this last day, but we have. And what this says on page 30, it says you should be able to identify the turning point of a parabola as well as its nature. So the nature bit we will speak about. We're mainly focusing on the minimum turning point ones just now, but the ones that have a maximum turning point are the ones where you've got a negative sign going on with a negative x squared one, but we will come back to them. But for the moment our focus is on the positive ones, so it's all about looking at the minimum turning point. If I ask you about the nature, we're talking about the minimum turning point. So what else do we need to know? We need to be able to write down the turning point, we need to know the line of symmetry or the axis of symmetry, we need to know the shape of the graph, so that's what I would call the smiley shape. If you're a positive x squared, you're a positive person, nice smiley face, so that's kind of the U shape is the other thing to remember about here. So if we identify with this, so you would be taken from the graph that we know it's going to be a minimum, so I'm just going to write MIN for short, TP for turning point, and from here I've got a plus 5, that means in my brackets it's going to be negative 5, and my y value is going to exactly match the negative 6. So coordinates that I'm looking for my turning point are negative 5, negative 6. My axis of symmetry will be the x coordinate of here, so I'm looking for x equals negative 5, and it doesn't ask you this, but I'm going to ask you to add this in, and we will write down what is the y-intercept. So the y-intercept, remember, is about subbing in y equals 0, so we do y equals 0 plus 5 all squared minus 6. That would give me none plus 5 in that bracket, gives me 5 squared minus 6, that's of course 25, take away 6, which is 19. So we end up with the y-intercept is the point 0, 19. So the second one, I need you possibly to change this. This might not match what you've got. If you could score out what you've got on your page and change anything that's different on my screen. So again, right, trying to identify the turning point, and it's a positive x squared, so I'm going to say it's a minimum turning point. The coordinates of the minimum turning point are, even though I've got a 2 here, right, that just looks the same as the last one, but you'll see in a little minute, we get the same turning point, we get negative 5, and we get the last term being negative 6. The axis of symmetry is still the same, but the one thing that will be different is the last term. So my axis of symmetry, remember, is x equals -5, but for my y-intercept, when I sub in this time, I'm doing y equals, I've got that 2 there, 0 plus 5 all squared, and the -6. Now that means I'm doing 2 times, I've got 5 squared going on there. And you can either use the calculator to do that or work through it on your own. 5 squared is 25, and 2 times 25 is of course 50. Take away 6 and you get 44. So this time your y-intercept would be the point 0, 44. So graphically these two graphs would be quite similar, the only difference being they've got the same turning point, but one is very, very much steeper than the other one. And we will look at sketching graphs in a little minute, but it means that's the y-intercept is an indication of that. So although they looked pretty similar, with the 2 at the front there, remember that multiplies the bracket. So it doesn't affect the turning point and it doesn't affect the axis of symmetry, but it does affect the y-intercept, and it means if you were sketching that graph, it would be much steeper. It's like twice as steep as the first one. So the last equation, writing down what my turning point is. So again, it's a positive x squared. So my minimum turning point opposite to the -2 would be 2, and it would match the last term, so it would be 4. So my minimum turning point would be 2, 4, and my axis of symmetry would be x equals 2. And then from there, writing down my y-intercept. So my y-intercept, I would be subbing in, right, y equals, and you've still got that 3 at the front, you've got 0, right, -2 all squared plus 4. So that gives me y equals 3 times -2 squared plus 4. -2 squared is +4. So I end up with 3 times 4 is 12, add 4 is 16. So my turning point, my y-intercept is the point 0, 16 this time. So same thing for each of them. Again, in your notes, if you haven't managed to complete it, pause the video, or else you can use the notes that will be attached on the online post and upload or copy from there. So what I need you now to do is look at page 31 in your notes, and on page 31 in your notes you've got a section that looks like this. You've got a bit here which, if you just put a line through that, this bit here on the left is the only thing we need to focus on, and what you'll see, we've changed the examples a wee bit. So this is saying I can sketch quadratic graphs, so this is our focus today, is to be able to sketch them. So you need to be able to mark down your turning point, you need to be able to find the y-intercept, and you need to sketch the graph through these points. So here, if we list what the turning point is, you can clearly see it's going to be the opposite sign of that. So -5, the y coordinate will match the 1 at the end. Your axis of symmetry is going to be x equals -5. To get your y-intercept, you're going to sub in x equals 0, so it's y equals 0 plus 5 all squared plus 1. That gives me 5 squared, add 1, 25 plus 1 is 26. So my y-intercept will be the point 0, 26. And putting these 2 points together will then allow me to sketch the graph of y equals x plus 5 all squared plus 1. So what I do, you don't need to draw this on a square grid, this can be done on plain paper, and you're just doing this approximately. So the turning point, right, is at the point -5, 1. So go a wee bit to the left of the 0, let's bring that back a wee bit, and up 1, right? That would be my turning point. And then I'm going to sketch the shape of the graph here because I know it's going to come down and it's going to do that and then go back up again. So key thing, right, this point here, we need to be able to tell the coordinates of that point. So list them beside it, minus 5, 1. And this point here is my y-intercept. And I want to be able to write the 26, the number, beside that. So let's have a go at the second one. You can see on this one, turning point is going to be at the point 2, minus 3. So although there's a 4 going on at the front there, it doesn't affect the turning point. It's still opposite sign of the minus 2 in brackets, so that gives you positive 2. And the y coordinate always matches. Axis of symmetry is x equals 2, x coordinate, and your y-intercept, you will need to sub in x equals 0, so you get 4 bracket 0 minus 2 all squared minus 3, so we're going to have y equals 4 times negative 2 squared minus 3, that's going to be 4 times 4 is 16 minus 3 is 13, so my y-intercept will be the point 0, 13. So I will need to plot the point 2, negative 3, that's my turning point. So you draw little x and y axes, make sure you use straight line, your ruler, to get the lines drawn. You're then going to plot roughly where 2 minus 3 would be, and we will label it. So 2 minus 3, we know the graph is a minimum turning point, and we know that it crosses the y-axis at the positive 13, so the graph's going to look like that. So this point here we can label as 13, and that would be your parabola shape, comes down to your turning point, and that would be you. So for each of the following examples, right, we're going to identify the turning point, state the axis of symmetry, find the coordinates of the y-intercept, and then be able to sketch the graph. So this is a wee bit of a summary. We begin by reminding ourselves that the most basic function, y equals x squared. So that one you just know has got a turning point at 0, 0. The axis of symmetry is x equals 0, it's the y-axis. The y-intercept is the same as the turning point, so you get the point 0, 0. So if you go right back to the lesson we did on Monday, it's the most basic quadratic is that, right? And that is just y equals x squared. There's your turning point, 0, 0, no other intersections with any other axes, that's it. If you stick a number in front of the y equals x squared, all that happens is it makes it steeper, right? 3 times x squared. You still get the same turning point, you still get the same axis of symmetry, and you still get the same y-intercept. So the only difference between the graph on the left and the graph I'm about to draw in here is that it would be a much steeper graph. Right, it will rise, but it's still got the turning point at 0, 0, and it just rises steeper. Now we move on to look at drawing the ones that we've been talking about with the completed square format. So with these ones, right, your turning point that you're looking for here, you would be using the point 2, opposite of negative 2, so 2, 3, that's my turning point. Axis of symmetry is x equals 2, and my y-intercept is going to be 0 minus 2 all squared plus 3, so I'm going to have y equals negative 2 squared, add on 3, that's going to give me positive 4 plus 3, which gives me 7. So my y-intercept is the point 0, 7. What I then need to do to sketch that graph, plot the turning point first. So I will be plotting the point 2, 3, that was my turning point. So roughly, right, this is best done on plain paper, right, these questions. So roughly the point 2, 3, I know it's a minimum turning point, so I know the shape of my graph is just going to do that, come down, hopefully to the turning point, and we will label the turning point with coordinates 2, 3, and also need to make sure we can read off the y-intercept at 7. And that's it. That's your graph that you're asked to draw. Next one, right, turning point, you can clearly see is opposite of +5, that's going to be -5. The y-coordinate matches, so you get -4. Your axis of symmetry will be x equals -5. Your y-intercept will simply be subbing in 0, so we get nothing plus 5 all squared. Right, nothing plus 5 all squared. And we have -4. So in the brackets, 5 squared is going to give me 25, take away 4 gives me 21. So my y-intercept is the point 0, 21. So I need to plot the turning point to get the graph drawn. So the point position of -5 would be along to the left of the 0, and then -4 brings me down here. I know that the y-intercept is a positive value, so my graph needs to be doing this, coming down, and we'll cross up here, and I need to label that as 21, and this point down here we need to label -5 and -4. So label the turning point -5 and -4, and that's it. That's your graph with a parabola shape. Right, these ones here, same thing. If you can check your turning point, +1, -4, axis of symmetry, x equals 1. Your y-intercept will be found by doing y equals nothing, -1, all squared, -4. So that's going to give me -1 squared, which is +1, take away 4, and that results in a -3 value. So my y-intercept will be the point 0, -3. So when I plot that, I would be plotting on my graph, right, my turning point first of all, which was the point 1, +1, -4. So I'm looking to, so 1, -4 would be sort of down here, and I know it's also going through the axes about here. So 1, -4, and then this point here would be -3. 0. I'll just move it. So this 0 here should be in the corner really. And that's your turning point and your y-intercept drawn. Right, last example. So looking for this turning point, there's the x coordinate in the brackets, opposite sign is 2. Oh, there's nothing at the end. Nothing at the end means the y coordinate will be 0, and your x coordinate will equal 2. Your y-intercept, when you do that, will be subbing in x equals 0, so you just get y equals -2 squared, which is +4. So the y-intercept is the point 0, 4. So we are going to plot the point 2, 0. That's on the x-axis, 2 along, nothing up, and my shape of my graph is doing that, and that's my y-intercept. And make sure your graphs look very roughly symmetrical when you're doing this. It's now your turn to practice.